Okay, this is my project. It's a 53 Studebaker pickup I've had for 50 years and proceeding to finally make it streetable and do it right. So that's what we got just for fun. Underneath I've got a 92 T-Bird rear end, fully independent. Fabricated the frame out of 2x6 rectangular tubing. Gonna run 2008 Mustang mags on it. And most importantly, what the video is about is a front suspension. And what we have here is a 2003 to 2006 Crown Victoria or Mercury Marquis front end. A lot of people use them because it's a nice compact unit. It's got 12-inch disc brakes, double piston calipers, rack and pinion steering, double wishbone, and a nice coil-over shock unit. It also happens to fit a frame that is 34 inches wide, which is your Ford truck and a lot of other vehicles. A couple of things before I get started on how to lower it. A couple idiosyncrasies. First thing is when you mount it, the holes are not symmetrical. You drill a hole, you put a half-inch Schedule 40 pipe in there, and that'll act, to keep it from crushing. Bolt it together, but the problem is this center-to-center dimension is not the same as this one. As you can see the offset, and I screwed up because I thought they were equal and did it that way. But there's enough of a slot in the upper control arm where that wasn't a problem, but down below I actually had to use an extended 5/8 drill and pop that through the frame and kind of drill a half hole to fake it. But if you do this in the future, make sure that you measure center to center here and center to center here because they're different. The other thing is the what the hell is it? The rear control arm mount. This guy from the factory is mounted at a 30-degree angle, and there's a slot in the bushing that allows it to move up and down for a caster adjustment. But it's a pain in the butt to try and come up with a 30-degree mount and all that kind of stuff. Plus, this little cap here centers the thing, so it kind of negates the slot. So what the hell, right? So what I did is this main frame rail is the same from where it mounts on the main cross member to back here, and this space here, and let me double check because I forgot the dimension. That is what is it, 1 3/4, right? Okay, so I made this plate out of 3/8 and it mimics the mount, and these are 7/16 bolts. So anyhow, it bolts to the plate, and this is actually shorter than what the what you would measure, factory. But the reason for doing that is that gives me the caster adjustment. So if I need to adjust the caster, I'll just put shims in here, and that way I can move her up or down and get the correct caster that I want. One of the other tricks I found, we're going to come over here, is the bolt. I don't know if we can see that here. Anyhow, that mounting bolt, the inner pivot, has an eccentric here, and there's actually a tab and all that comes that locks it in there. But if you grind it all off, now you have this eccentric, and you can actually adjust the camber by rotating that. So that's something you can modify and make work to your advantage. The other thing is the U-joint which I'll have to say who makes it. I think it's a Borgson or something. But the thing is about this is it's the stock U-joint is a piece of crap. I mean, don't even bother. It's such a goofy looking arrangement. You can't adapt to anything. Looks like hell. So the shaft on this end of it is either a Pyramid or a Mustang V. Same thing. But unfortunately, you buy the Mustang one and it's just that much smaller. So you have to grind down the shaft on the rack. And you don't want to go overboard with it. So what I used was a flapper wheel on a die grinder and just carefully went around, and a little here and a little there, and try it, and a little here and a little there, and try it, and just keep playing with it until it just fits on. It's a nice snug fit, and then it works great. The upper end for me, this is a 3/4 inch double D, which is the shaft I'm using. They make a lot of different shafts, whether it's splined or square or anything. So there's a lot of variety. Come on, let's get our focus going here, boy. Anyhow, so that that's kind of the idiosyncrasies of the suspension. The problem I'm having is that the thing sits too high. And this is fully loaded here. You can see the lower control arm is still at a downward angle. And this is, well, except for the front sheet metal, which doesn't weigh that much. I've got a 300 inch 6 I'm running, and it weighs about as much as a small block V8. And you know, it just obviously is not as much. I've seen the suspension where they have a full-size Ford truck with a big block in there, and it sits wonderful. It's great, but in my application, it just doesn't work. I could jack up the rear end, but then the whole thing sits too high, and there's too much space between the wheel and the fender, and that doesn't look right. So I would like to lower the front end so it looks better and rides better. A few suggestions, less than helpful suggestions that have come through is, one is to Z the frame, but I've completely modified it and all, and that's not going to work because nothing will line up anymore. The other is to actually cut this top and build like a hat and raise up the mount, but this is aluminum, and to fabricate it and weld it and all that kind of stuff, which I'm perfectly capable of doing, is a lot of work. Plus now, how is the camber going to work and everything? It's just, just not something a person would want to do. But I've come up with a way to drop it, 1.5 inches, and it puts her down there where it looks decent, but it doesn't really change the articulation of it. It's a fairly simple modification. It doesn't involve any welding or anything like that, but it seems to work out pretty good. So the next part is going to show exactly how I did that. Okay, this is what you're going to make. These little plates. You're going to make 4 of them. 2 for each side, obviously. They're 1/4 inch plate, and it's just mild steel, nothing special. What I have is a better picture of the dimensions, if I can get her. Okay, and what we have here is the plate itself, and these are pretty rough dimensions. It's not super exact. The only critical part is this 4-inch radius up here. The original lower control arm has a fly cut in it, and it happens to be a 4-inch radius. And this will let that plate fit nice and snug up against there and kind of keep her from rocking and attach it better. So what we have here is a 4-inch radius. It's about 3.5 inches wide, 3 1/8 tall, with like a 3/4 inch radius here and a 1/2 inch radius here, more for aesthetics than anything else, nothing really critical. The other side here is our hole dimensions, and these are a little more critical. So we've got a 3/4 inch hole, and that's 7/8 from that. That sits are nice and snug. I've got additional 3/8 bolts attaching this, just my own paranoia here. I want it nice and secure so it's not going to go anywhere. And these are not super exact, just so that they look decent and have a good spacing. So roughly 2.5 inches to center, 3/4 inches down. The drop position is 1.5 inches down. So just come down here, pop a 5/8 hole, and that's it. That's pretty much it. Just, shiny her up and make her look pretty. Okay, something I forgot to mention, the reason why we can do what we're doing is this right here, is we have, whoops, where are you? 1.5 inches of clear area that we can drop this guy down, and without it hitting, and that'll lower the whole thing 1.5 inches. So that's where we come up with that dimension. Okay, now I got the lower control arm off, I'm going to show you this guy here, and you can see where you cut it off here, because there's that tab, and that takes that off, leaving this eccentric. So now that's just going to adjust, and you get your camber adjustment through that. Now the beauty of this is this hole right here. This is the factory mount, and it just happens to be a close enough size to the tap drill for a 3/4 tin tap. So we'll tap this guy and put some threads in it, and then we can attach our plates. Well, you get the idea. I'll finish that later. Now something else, while you have it apart, and since it's kind of a involved process to tear everything apart, because you got to pull the rack and everything else, do everything at once. But these guys here, the ball joints, the factory says throw the entire arm away, get another arm. Well, yeah, if you're made out of money, sure. But you can buy replacement ball joints, but they are a royal pain in the ass to change out. The lower ones, I heated it up and used a press, and anyhow, it was a disaster, but I got them put in. The upper ones are even worse, where this guy here is pressed in, but it's so good you can't get it out. So what I had to do is actually take disassemble the thing, grind the end off, and pop the guts out, and then take a torch and cut a slot in it, and that relieved the tension, and you could press it out. And it's not a job for amateurs, because if you don't know what you're doing, you're going to put a cut in here and you destroy your entire control arm. So if you know what you're doing, that's, I don't know, maybe there's a better way to do it, I don't know, but what a pain in the ass. And then it takes, a couple tons of pressure to push the new one in. Just saying. Okay, next step is drill and tap the 3/8 holes. Just run it completely through and thread it. And what I'm using is a 3/4 inch long bolt with a lock washer. And that comes out about the right size, where it doesn't penetrate the back side, but still you get full engagement of the thread. So that's our next step. I want to show you here. You can see how this radius just fits in there nice, and you're not going to get any wobble or anything. So that's going to be in there. These guys are going to lock her solid, and anyhow, it'll be a good solid mount.